Hello, welcome once again to another important, essential, and exciting tutorials on rules of differentiation in mathematics, calculus 1. So today we want to look at the product rule. The last time we met, we spoke about the various types of rules that we have. We have the product rule, we have the power rule, we have the quotient rule, and we also have the chain rule. And the first, you can equally differentiate equations or functions using the first principle. But the last time we met, I said that for the first principles, there are certain functions that become very difficult to differentiate using that particular method. So with that, other methods came on board to assist. So we looked at the power rule. So for today, we will be looking at the product rule. What does the product rule says? And how is it applicable in calculus or in mathematics? Come with me. Let's dive deep into the lesson. When we talk about product, what comes to mind is multiplication. Multiplication, which is the times multiplication in basic mathematics. So product simply means times. Or when you go higher or for further studies, we normally use dots. Sometimes we use dots for multiplication. So with that, we are going to use that to solve questions or to differentiate functions if using the multiplication rules. So for instance, if we have y is equal to vu, when you see something like this vu, it means there is what? Multiplication here. Or there is what? A dot. So v multiplied by what? V multiplied by u. Or v dot u. So if we remove the multiplication signs, we can quickly write v u. So that is it. So we will remove the dots. But in your mind, you should know that when we have two variables coming together, we have a multiplication sign in between them. So I hope you get me to that point. So y is equal to vu. So how do we differentiate it? The differentiation says that rule says that dy over dx, we are differentiating with respect to x. What we are going to do is that we hold one of the variables, then we differentiate the other. You hold one of the variables, meaning that you hold it constant. You make it constant, then you differentiate the other variable. Then you now add it to what? You hold the second variable constant and differentiate the first variable. I'm speaking too much English. Let's dive into the lesson so that we do the differentiation. So now, this is our first variable, which is u. So we hold it. So v. The first variable is what? V. So we hold v and we differentiate u with respect to x. So with the differentiation, since you hold v, you differentiate it. Whatever you get, you multiply it with the v. So when you differentiate u with respect to s, you get du. Let me put a dot here, signifying multiplication. Du over dx. Then we add it to, you now hold what? U. Then you differentiate v. So we hold u. This is a multiplication sign. Then now let's differentiate v with respect to x. So we have dv dx. I believe you are following. Good. Now let's polish it so that it will look nice or it will look good. So v multiplied by du over dx gives us v du over dx plus u multiplying dv ds gives us u dv dx. So this becomes the general formula which we use to solve issues involving or questions relating to the product rule, or questions that comes in a form of what? Two functions multiplying each other. So this is the particular rule, or this is the rule we normally use to do the multiplication, to solve questions that has what? Products in it or multiplications in it. So with this, let's take some few examples and see how we can use the product rule and the way questions are normally set. So you look at that and you take notice of that. So let's dive deep. Let's take some few questions. There are some sample questions that needs the product rule. So you could see from the question that we have one set here and we have another set. What is joining the two sets is what? A dot, but it is not written. So far as it is in this form, it is a product. We have to use what? The product rule. You can equally see we can place 2x cubed in brackets. So when we do that and we have the second bracket, it becomes what? We normally use the product rule. Likewise, question 4 and question 3. So you can see that question 2 and question 3, they look similar. So with that, how do we solve it? First of all, if you want to solve any mathematical question, if the question is not lengthy, you write it down. So we have 2x plus x squared multiplied by 3x plus x cubed. So how do we go about it? We already established the fact about the formula which we have what? We have our dy, we have our y, which is equal to uv, or v multiplied by u, or u multiply v, because multiplication is commutative and it is also associative. Good. So after differentiating, we have what? We have our dy dx giving us u dv, v du over dx plus u dv over dx. So this is the general formula that we have on board. So meaning that before we'll be able to get the solution or the derivative of the first question, we need v. Then we need a differentiation of u dv. Then we need u. And we also need differentiation of what? dv ds. So from this, which one is the v and which one is the u? When we are reciting the alphabet, u comes before v. U comes before v. So what we normally do is that the first bracket is mostly given to what? To the u. First bracket goes to what? U. And then the second bracket, that the first one is multiplying, goes toward v. So let me take that again. What we normally do is that we apportion the first brackets to u, because u comes first when you are reciting the alphabet before v. So u goes to the first bracket, v takes the second bracket. So that is what we are going to do. So our u is equal to 2x plus x squared. Now we differentiate it to have our du dx. So when we differentiate with respect to x, we have, yesterday I told you how to differentiate. We have 1 here. We drop 1, it will multiply the 2. So we have our 2 here. Then this one will be what? Will be 1 minus 1, which we know that it is 0. So when we are differentiating a constant with just a variable, we have what? We differentiate this, you have 2. Then we differentiate 2x, we'll get 2. Then when we differentiate x squared, we'll get 2x. When we drop the 2, it becomes 2x. Then when we subtract 1 from the 2, we'll have just x. So in all, it will produce 2x. So That is the differentiation of u. Now we take v, which is the second bracket, which is 3x plus x cubed. So our dv by dx will be equal to, when you differentiate 3x, you will get 3 from our previous lesson. Then when we differentiate x cubed, you will get what? 3x squared. So that is the differentiation of what? The v. So now you can see that we currently have our v, which is here, our u, we have our u. Then we also have our du over dx, which is here. Then we have our dv ds, which is also here. So what we are now going to do is that we just take the formula, then we do substitution. And bam, the answer will just pop up. Or the differentiation will just what? The final answer will just pop up. So we have what? Our dy over dx now is equal to, you state the formula, v du dx plus u dv dx. What is our v? Our v is 3x plus x cubed. What is our du? Our du is 2 plus 2x. 2 plus 2x. Then our addition comes in. What is our u? Our u is 2x plus x squared. So we write it 2x plus x squared. Then our dv is 3 plus 3x squared. So we write it 3 plus 3x squared. Now, let's do the multiplication. Let's open the brackets. Algebraic expression. So 3x will go and multiply 2. It will give us 6x plus 3x will go and multiply 2x. It will give us 6x squared. Then we have x cubed multiplying 2. It will give us 2x cubed plus x cubed multiplying 2x. It gives us 2x to the 4th power. Because indices, you just add the powers. Because we have s here. There is 1 here. We add the power. Then we move to the second bracket. 2x multiplying 3 gives us 6x plus 2x multiplying 3x gives us 6x cubed plus x squared multiplying 3 gives us 3x squared. Then plus x squared multiplying 3x squared gives us 3x to the 4th power. Now what do? We group like terms. The 4th power comes first, followed by the 3rd, the 2nd, then the 1st. So we have 2x to the 4th power, then plus 3x to the 4th power. You can't find anyone again. Then we move to 3 plus 2x to the 3rd power plus 6x to the 3rd power. Then we move to 2. Then we have 6x to the 2nd power plus 3x to the 2nd power. Then plus 6x. Then we also have 6s here. 6x. Good. I hope you are following. So 2x to the 4th power plus this, it gives us 5x to the 4th power plus 2 plus 6 gives us 8x cubed plus 6 plus 3 gives us what? 9x squared. 6 plus 6 gives us 12x. So with that question, this is the solution for the question I. So when you differentiate this using the product rule, this is what you will get. You get 5x to the fourth power plus 8x to the third power plus 9x to the second power and plus 12x. So let's take the second question. Two x cubed, 5x squared plus 2x negative 2. Okay, so this is the second question. 2x cubed, 5x squared plus 2x negative 2. So I said early on that the first bracket should be given to a u. So from here, our u is equal to 2x cubed and our v is equal to 5x squared plus 2x to the power negative 2. So now let's differentiate. So the u over the x gives us what? When we differentiate, you use the 3 to multiply the 2, we have 6x. Then you subtract 1 from the 3, then you have 2. Then we have the u over the x. What do? Use the 2 to multiply the 5, you have 10. X, subtract 1 from the 2, you have 1, so we don't write it. Now, use the negative 2 to multiply the 2. You have negative 4. X, subtract 1 from the negative 2, you have negative 3. Now, it means that we assess. Our duty is now to do the substitution. So, our dy over dx is equal to v du dx plus u dv ds. So, we do the substitution. Our v is 5x squared plus 2x negative 2. Then our du gives us 6x squared plus our u. What's our u? Our u is 2x cubed multiplying our dv. dv is 10x minus 4x to the third power, or negative 3. So let's open the brackets now. So dy dx is equal to 6 will multiply 5x. It will give us 30x to the fourth power. This and this will give us 30x to the fourth power. And this and this, it will produce, this is what? 12. And this will also produce 0. Because negative 2 plus 2, it will produce 0. So this will give us 12. Then plus 2 will multiply this, we have 20. So we have 20x to the fourth power minus, this will give us 8. Minus 8. But this is positive and this is negative. So it will produce 0, which is what? 1. So it is 8. So what do we do now? So our dy over the x will be equal to, we group like terms, 30x to the fourth power plus 20x to the fourth power plus 12 minus 8. So we have 30 plus 20 gives us 50x to the fourth power plus, this will give us 4. So we have 4. So our final answer for the differentiation of the question 2 is 50x to the 4th power plus 4x plus 4x. Let's quickly move to the third question. Third question is now 3x squared. Our v is 2 minus 4x cubed. When we differentiate u with respect to x, we'll get du dx giving us 6x. Then dv over dx gives us, when we differentiate a constant with below, giving us 0. Then when we differentiate negative 4x cubed, it gives us negative 12x squared. Negative 12x squared. Then our dy over dx, which is v du over dx plus u dv over dx. So our v is what? Is 2 minus 4s cubed. Our du gives us what? 6x plus u gives us what? 3x squared. Then our dv gives us negative 12x squared. So what do we have now? Our dy dx will be equal to 2 multiplied by 6 gives us 12x. Then negative 4x squared, sorry, s cubed multiplied by 6 gives us 24, negative 24x to the 4th power. Then 3x squared multiplying negative 12 gives us negative 36. 36x to the 4th power. So what do we have? Our dy dx, we group the like terms. So we have 12x minus negative 24x to the 4th power. Then you would minus again negative 36 to the 4th power. It gives us 60 x to the 4th power. 60 x to the 4th power. So that's the solution. So let's make it 2 minus plus of 3x to the 4th power. Okay. Okay, so let's solve the 4th question. Solution for the 4th question. So you already know that our u is the first bracket, which is 4x to the 3rd power minus 2. We differentiate du over ds. It gives us, this will give us 12x squared. Constant will blow, it will give us 0, so we leave it. Then we'll have our v. Our v is 5x squared plus 3x to the 4th power. When we differentiate the v with respect to x, we'll have this will give us 10x. You just use the 2 to multiply the 5, then you subtract 1 from the exponent. Plus, use the 4 to multiply the 3, giving us what? 12. We subtract 1 from the exponent, 3. So we are good to go. We are now good to go. So our dy over dx, we state the formula, the product rule formula, which is v du over dx added to u dv over dx. So now we do the substitution. So our v is 5x squared plus 3x squared, 3s to the 4th power, multiplied by our du, which is 12x to the 2nd power. Then added to u, our u is 4x to the third power minus 2 multiplying our v, which is 10x plus 12x to the third power. Okay, so now let's multiply. Let's do multiplication. Let's do multiplication now. Our dy over dx. 5 will go and multiply 12. It will produce 60. 60x to the fourth power. 60x to the fourth power plus 3 will go and multiply 12. 3 will go and multiply 12. It will give us 36. 36x to the 6th power. It will give us the 6th power because indices, when you add 4 to 2, you get 12. Sorry, you got 4 to 2, you get 6. Then add 2, 4x cubed multiply 10, we have 40x to the 4th power. Indices x cubed multiplying x. Then we also have plus 4 multiplying 12. It gives us 48. 48 to the 6th power. It was cube. Then we have negative 2 multiplying 10 gives us 20x minus negative 2 multiplying 12 gives us 24x cubed. I hope you are following. So dy, dx, we group like terms. 6 will come first. Exponent 6 will come first. So 36x to the power 6 plus 48x to the power 6 plus 60x to the 4th power plus 40x to the 4th power, then plus or minus 24x to the 3rd power, then minus 20x. So dy dx 36 plus 48. Which is 84. We have 84 here. Because this is 14. 1, this and this 7, 8. So we have 84x to the 6th power plus 60x plus 40x gives us 100x to the 4th power. Then we have minus 24x cubed minus 20x. So this is the solution for the 4th and our final question. If you have any challenge, you need kindly go over, solve this, and resolve it again. So we meet again. I say bye-bye for now. When we meet, we will solve issues relating to the quotient rule.